All right. Well, this is why I have the chat here. So we're going to step back. I'm going to start right from the beginning. Thanks a lot, Andre, for letting me know. So this is probably what I should do all the time at the beginning. Can you hear me now? Shuano and Andre, can you guys hear me now? Can you hear me? Hello. You might be seeing a small delay now. But yeah, I'll wait. Okay, it works now. All right. Awesome. Well, first of all, now that we're here, I'm just going to slide back a bit and we'll get started because I've recorded myself with no voice for how many minutes? I don't know. Maybe 6 minutes or something. All right, let's get back here. All right, first, thanks for connecting online. Can I hear a bit more about where you're connecting from or what your interests are before we get started? Maybe we can wait for other people to connect as well. All right, so if okay, I just want to give you some time, guys. If you okay, Sweden computational designer. Well, thanks Andre Agi for joining us today, and thanks Shuano as well. Thanks so much for letting me know there was no sound at the beginning. So we're gonna get started once again. So for people who come in, please say hi on the chat and maybe where you're coming from. Okay, Shuano from Spain. All right, I'm gonna get back at where I was. Well, hi everyone. Let's try this again, right? So hi everyone, it's Nono here, and today we're gonna see the second day of the live stream. So as I mentioned before, so this is the second, so this is the third live stream that we do. On this one is the continuation of the machine learning series, and today we're looking at suggestive drawing part 1. So part 1 of the suggestive drawing series, we're going to be taking a look at some research that I did before, the technologies that I use, the workflows, what machine learning models, and many other things, the data set, how I build the data sets, and many other things. Today we're just going to try to do a refresher on what suggestive drawing is and try to establish what we're going to be doing over the next days. Hi Random Adam. I would like to remind you guys, so for the people who are watching, that if this is the type of content that you would like to see in the future in my channel and in future videos and talks that I produce, please go ahead and like the video, because this tells me that this is the content that you want me to be focusing on the channel, and in this case on the live stream. And also, if you'd like to receive notifications when I publish new videos and when I'm going about to go live or when I schedule live streams, go subscribe and click on the bell. All right, as I said before, it's Nono here, and this is part of the machine learning series. As a recap, for the past 2 weeks, we have done the 2 first live streams, and just last week, I tried to cover an introduction to global technical concepts of machine learning, things having to do with frameworks, with some books that I recommend, with where you can learn more and things like that. And I have trimmed these videos to make sure that we can publish them as individual clips, so you can focus on seeing them and you don't have to watch the 2-hour long chunk if that's not what you want to do. What we have here is, one first video that introduces what machine learning is, really briefly. The second one shows you how to use Python and create custom Anaconda environments to have, for instance, multiple different versions of TensorFlow installed on the same machine and use them at the same time. and what Jupyter notebooks are. Then we go into Colab. So Colab is just an extended or augmented version of Jupyter Lab. And I show briefly how you can use it and how you can get to use GPUs to train machine learning models in the cloud for free. And along with that tutorial, as a separate clip as well, I show how to visualize TensorFlow tensors as images. And this is just so you can understand a bit the data structure that we're working with on TensorFlow. Well, thanks for your comment, Random Adam. I'm glad you like the content. If you want, you can let me know a bit more what kind of content specifically you're referring to, if it's about the podcast or the videos or what content you're referring to. And hello, Lourdes from Spain as well. So, okay, so what is suggestive drawing? Suggestive drawing is the title I gave the project that I presented at the Harvard GS School, so at the Harvard Graduate School of Design, the Harvard GSD, as my master's thesis project. This was sort of an independent study and a project that I did with the guidance of Panagiotis Michalatos from Greece. He was teaching at the moment at Harvard. And this project tried to explore the role of machine learning and artificial intelligence from the perspective of an artist, of a drawer. Not necessarily an architectural designer or a designer, a formal designer, but somebody who just trying to make a drawing. And you know, I tried to come up with a description or a definition of what suggestive drawing is, just so we're all clear on what I think this is, and it's clear for the rest of the videos that we're gonna see. All right, so let's step back. Hi, it's Nono, and this is just an introduction to what suggestive drawing is. Suggestive drawing is the act of drawing along recommendation systems that collaborate in the design or art process by providing you with suggestions, right? So it means that while you're doing a process, a creative process, like it's drawing, I mean, it could be deterministic if you're following some path that is has a set of predefined steps, but usually drawing is sort of an undeterministic step where every time you create a new stroke, you reevaluate that drawing and want to take a new decision. So in this system, you have recommendations, as you have on Netflix. When you end watching a show, you get recommended to watch similar ones. In this case, those recommendations are drawing suggestions. There might be textures or might be a suggestion to rationalize your drawing or to do something else. Going a bit more in general terms, suggestive creation or augmented creativity could be the act or interaction of creating along recommendation systems that collaborate in the design or art process by providing suggestions that augment the creative capacity of the artist or designer. Augmented creativity or suggestive creation is no more than doing the same creative process that you're doing, but with an agent that is trying to provide with suggestions that hopefully impact your process to make it better and make the result a bit better, maybe a bit more productive, a bit more accurate, or something that makes it be a bit better. One example I can think of is Gmail's autocomplete, right? As you're writing an email, it tries to autocomplete your sentence, and that suggestion usually will have good grammar, and you might have skipped mistakes or had found a shortcut to get to where you wanted to get, or to what you wanted to say. All right, this is an environment that I created. So this is the app, so the client application that I created for iPad, where I was just sketching. Let's see that once again. So I was sketching a flower, and maybe it's hard to see, but there is like a blue aura that demarcates that this is just one drawing. And when that disappears, you can see there that there is like a little thumbnail of that layer or that new stroke that has been grouped. In this diagram or interface, we can see here at the top, we can see that's a human that's done the drawing, and then right there, we can see that that's a human drawing. So we have a human doing this drawing, and then a layer that is encapsulating that drawing in the system. So there is now above me two agents, two bots that, as I finish this drawing, provide two suggestions, right? So we have the daisy bot and we have the sunflower bot. They only know about those. So if I draw a house in this system, they're just going to try to propose the texture of a flower. They don't really know anything else than daisies or sunflowers. And then what we have on the right is that above my drawing, daisy added the texture of daisy, and then sunflower added the texture of a sunflower, right? And that in the system play a role as suggestions. So we have two suggestions that on the system I can double click and hide, or I can keep for my drawing as a suggestion to continue drawing. This is a system that we've later further developed. This is a project that I did in collaboration with Nate Peters, which is just using the same daisies model with Runway to request predictions in real time. The difference here is that the suggestions are being generated next to the original drawing and in a separate canvas, and not exactly on the same canvas as they were being generated on the previous slide. Here we have the final prototype that I developed for the iPad. So that interface that I was showing you there, this is how it looks when it's used with my with the Apple Pencil. And what you see is that as I'm drawing, I don't have to stop until the suggestion comes. There is an interaction that happens where I can continue drawing the next flower with just one bot next to me. So right there is one bot that is listening. So every time I draw, it receives that grouped set of strokes and then process it through a machine learning model that is called Pix2Pix in this case, creates a suggestion and then sends it back my way. Right, and these are some of the drawing results. In this one, the slide, you can see Lourdes did the one sketch from the cathedral, for example. We have Lourdes online here today. And some other people sketch the other ones, right? So these are different people using different machine learning models or bots that were trained with different data sets and producing an outcome with texture. So here the human only did drawings of, so outline drawings with outline strokes, and it was the machine or the bot who was generating predictions for textures that could match the shape in the drawing. You can see, for instance, that on the sketches of the roses, on the flowers, it actually fills the top with red and then the bottom with green. In the case of the trees or the house, it's trying to fill with texture that looks like leaves or tree trunks. On the cathedral, it actually looks like texture of a building, and then on the sunflower, it actually manages to put the center of the sunflower as dark, the leaves as yellow, and then the tail we'll see now, I think as green. Yeah, and the leaves as green, sort of between yellow and green. And also, one thing that is really important is that I'm using the strokes of the person as a layer mask to crop the rest of the drawing. So initially, this network actually generates something like what you have on the right, that is just like a square image with background and stuff. But if you compute the Boolean union of the entire set of strokes and use that as a layer mask, then you can get something cropped, like you can see on these flowers. All right. Okay, so one thing before we get started with taking a look at some more stuff, I would remind you or let you know that at that URL that you can see here, you can download a PDF version of this publication, of this project that I did. And you can also go to suggestivedrawing.com just to see many of the things that I've shown today and a lot more diagrams and explanation. So you can extend a bit more and understand a bit more what the project is all about, right? So this publication was actually really successful in communicating what the project was about and the intent or the proposition that I was trying to make with this sort of interactive interface where the bots would be connected to a client app in real time, but then we would be requesting asynchronous prediction from them. So the results wouldn't come back to us instantaneously, but we will have to wait for a bit to get them and see them on screen. All right, and something that is important, we're gonna also try to cover in the next few weeks are data sets. So these are, for example, many circular strokes that I did on the platform that, when I was trying to develop it, that you will do many different strokes with different sizes and different width and thicknesses. And this would be stored on the server. So each of these individual strokes would be stored on a folder in a computer where the server lived. And we're gonna try to make use of all of these things during the next videos. And you will be able to, we'll hopefully be able to do something of use with this. Again, naming Lourdes that is online here. So this is a data set that was generated by an artist. And what you can see is like those trees. Let me just zoom in here, for example, to these trees, right? So this is textures of trees that have been hand sketched. So this is not generated by a computer. So all these are like, maybe each drawing was 15 or 10 centimeters high. And the thing that you can see on the left, so the outline was extracted with Mathematica, just with like a few image processing steps where we could obtain the outline drawing. In some cases it was really good, like here, but in other cases it wasn't that accurate, like here. So it was a bit different, because actually the drawing is like that. So there's like this white area here. So yeah, but the thing is that just with 64, 65 trees, we were able to train a generative network that was interpolating or like trying to come up with pretty good results. I can actually show you here. So we go to suggestivedrawing.com and we go to trees. Yeah, so this is actually the network that was generating images of trees. One thing that's cool here is that as the trees are being generated, both, and this is sped up, of course, so what you're seeing here is not real speed in most cases. What you can see here is like that blue rectangle that happens to group the sketch as you're drawing. It's like a temporal barrier when the system would say, okay, this is one stroke and I'm going to save this as a separate layer. So there's no interaction on creating new layers and saying, okay, let's separate this part of the drawing. It's more about a temporal relationship where you can intuitively get used to that and just be sketching with your pen. Every time that you separate the pen from the screen for a few seconds, one of these outlines, so the actual drawing, would be saved as a separate screenshot or thumbnail, be sent to the server, and then we'll receive the prediction or the suggestion from the bot. Maybe, in this case, I think it was taken from 1 to 4 or 5 seconds per prediction, and there were many different models. So one individual of these bots, you will be able to right click, and then I will have some options. I don't think I'm gonna be able, well, maybe I can pause this video here and show it. Yeah, here. So each of these bots would have a channel that they're in. So depending on the channel, this represents the drawing number at the end of the day. It will have a pix-to-pix model. In this case, dandelions. You could change to trees, you can change to other things, and you would get some feedback, sort of like a console here, uploading my suggestion, processing stroke, generating pix-to-pix image. There you go, upload. It will give some feedback here on the UI while you're developing, so you could understand what was going on. And I think, if we pause in some part there, we can see a bit more of that. Let me just see. Yes, it's pretty fast. Yeah, You see, so we can change the drawing number, and here the data set was urban sketch. So we were trying to make the network feel textures as if, you know, this was buildings, and in some way, I don't know, it tried to just fill this with watercolors or something. All right, so let's get back to the presentation. And you know, this is another thing that I sketch with the system, and I always tend to show this because I tend to draw illustrations like this one, black and white, but I never put the effort or just have an idea to go and color it. And what this shows is that the system has provides its own character to my drawing, so it suggests a way in which I'm going to change or alter the drawing that I'm doing in a different way in combination. And this is sort of the augmented creativity concept that I was mentioning before, created suggestive drawing. All right, so that's for the slides. So this is the content that I had today, just to go through in terms of slides. And what I have here as well is, you know, we went through this, and what I'm just gonna try to do today, so just a brief, really brief overview on the things that we can do in next steps. And what I'm expecting from you is that you let me know what things interest you more and what things you would like for me to cover in the next weeks. So yeah, let's get started. So let's see. The suggestive drawing application that I did how many years ago? Three years ago. I had, let's just zoom in here a bit. So I had to prepare data sets. So we had to prepare a bunch of data. So data was super important. So it was one of the things that you had to do from the very beginning. You have to gather data and format it, learn how to format it in a way that a machine learning model can get it, right? So let's say that the step one was gathering data. So, you know, the steps for next week's. So step one was gathering data. Step two was finding or choosing a machine learning model that we'll use, because I don't know you, but I don't know how to develop a model from scratch that is a generative network, something that can generate an output from a given input, say an image. And then the third one for me was development. First, learn how to use machine learning model, then create a program to request predictions from, right? For me was like the model that I found was Pix2Pix. And then what I had to create as well in this system, as well, that this is not something required all the time, is first a client application. In this case was an iPad app coded in Swift, and a server application that was running on my machine, could run on the cloud, and was written in Golang, right? So let's just make this here. It was an iPad app, so the client application was actually a drawing application that had the concept of interface with canvas, well, say layers, and users connected, or agents, right? So agents could actually be humans or bots. So let's just put this here as well. And I have here some other steps like CocoaPods and upgrading the Xcode Suite project to the latest version, the goal and backend. So what I would like to do in this series is so that we can go back to the information that I have and try to make sense of it. Hopefully generate new data sets, gather data, find existing, things that we can do is find existing data sets, maybe scrape images from the web, maybe create our own data sets, for example, like custom drawings, and this is something that I have, and use strokes from Suggestive Drawing system. All right, so these would be not the steps for next week, the steps maybe to build a suggestive drawing system. And we could also explore here the machine learning model. So this is datasets, this is machine learning model, and this is so client app, server. For the client app, in this case I used Swift. In the case that I was mentioning before, that I built with Nate Peters, I used Glitch. Or we could use also React, so the React framework to build a web application. Right. So yeah, let's take a look. And the machine learning models create a program to request coedition. These were actually my pix2pix, well, the bots. These are those tiny, each of these agents that knew how to do something. It was just like a separate trained pix2pix trained model. And data sets. All right, let's see what we can get to today. So we're at 7:06, so I'll probably stay here 1 more hour or 30 more minutes. And right now I'm just gonna make a little pause. How's everyone that is connected? How's everyone doing right now? I would like to hear from you. If you just connected, if you just joined the live stream, where are you connecting from? Maybe what's your name? Where are you connecting from? And what would you like to see in this live stream series? And I'm gonna get some water while you reply. I'll be here. Hello. So we're back. All right. Hello, Bea. I see that you're connected. Where are you connecting from? Right, let's go back to our note. So, we have here a bunch of things that we're going to be able to do. And one of the main goals of the next few weeks is going to be to try to build one of these applications from scratch. Something that if you follow the steps, if you watch these videos, hopefully everything will be there and you're going to be able to reproduce it on your own and build something similar. Hopefully I'll get some of this stuff ready for open sourcing as well, so you can have access to the code. Right now I have the code on a private repository in GitHub because I have to sort this stuff, and as you can see I haven't touched it in a while. But we have a few main tools that are of interest for this series. So we have if I don't remember wrong, we have the client Go. We're going to open. We have the server in Golang as well, and the iOS application. These are the main components, and I don't expect you to know Golang. If you come from a design background or architecture, maybe you know other programming languages like Python, maybe C# or JavaScript. I don't know. Maybe you can comment on the chat or in the comments to let me know what programming languages you've used. And what this client does, we're gonna try to see. We can see it here. This is in Golang, so if you haven't done Go, the syntax of this language is a bit weird. I would say it takes some time to get used to it, but Go is supposed to be one of the most efficient back-end programming languages that are out there. And I just wanted to use Golang in this project to try it out and to see how powerful it was. What it allowed me to do is to have multiple handlers where both the server and the bots would receive requests. So say, okay, I have a new image here, give me a prediction for that image, or for the server would be able to dispatch an image and send it through WebSocket to many different clients. So I haven't mentioned, so the architecture of the project itself was using WebSockets. So let me see, I think I have a video on YouTube on how to use WebSockets. So this is just like a tutorial that goes and explain what
one of the most common examples
what WebSockets are and how you can use it for to build interactive applications where multiple clients can connect to a network and they can interact messages in this case. But at the end of the day, a message, so a JSON message, can encode not only text but can encode things like you see here, like a drawing strokes or images or any other type of data. And you can, one client can author or the server can author some information or notifications, and it can be sent in real time to all other clients that are connected to the server. So yeah, go to the channel and look for this video if you want to learn more about it. We're not going to cover it today, but probably some other day we'll cover some of these topics in the channel. All right, so handlers. So I have here, I'm just gonna briefly touch and try to refresh my head a bit on the code that we have here. This is code for each of the bots. So each of those I mentioned before, there is one that is the daisy, one that is the sunflower, and they would have the ability to connect to a WebSocket server that was the backend server. And what this was doing, this piece of code was doing here, is get the string value of the action property of WebSocket, of the JSON message that was passed through WebSocket to the clients, and reading that. So let's say that the action is new stroke or something, and we would have all of these ones as possible values. So you would be able to receive maybe a notification, a message, a client ID, distribute the stroke, option value changed. So when you distribute stroke, what this was doing, this is the most important, is that somebody was drawing on the iPad or the iPhone, and this stroke, so this piece of drawing was being sent over the network to the server, and then the server was distributing that stroke to all other clients except for the one that had drawn it. This allowed for other people who were connected to receive that stroke if they were drawing on the same canvas, and for bots to receive the drawing, at least the raster representation of it and the strokes as a vector, and processing it in some way. For iPad clients, it was actually just rendering it on screen at the right location, coordinates, and scale. For bots was obtaining an image representation of it, sending it through the neural network with the model that was selected in that bot, creating an image as an output, and then sending it back to the server. Option value change was, to have a way to communicate to bots that we wanted to change the model ID or the name or the channel that it was sketching on. Client ID was a unique ID that the server allocated each client when they connected to a new server. Message was just a notification, so they could display a message on their interface, maybe on their console where these bots were running, and a notification similar to the message. For each of these, right, so for instance, for distribute stroke, if you receive an action and the action type is distribute stroke, you would run the distribute stroke handler. That's like a function that you can see here that would execute all of this code. So this is a lot of code actually. Yeah, so this is probably a bit of a spaghetti code that we could improve. But this was because different models needed different things, and just this one function takes 500 or 400 lines of code. What this is doing is obtaining the message and what client sent it. What we want to do here is process the message that is coming our way, which contains information about where the image is and what image it is and things like that, and keep a reference to the client, because later we're going to send that response that we generate, and we want to know who the client is so they can reference it or display it. So let's see. So we have here handler pointer. So I'm just gonna look for that. And that's one key here. So for me, I created different sorts of bots and they would all work with the same program. And the only thing you did is I want you to be a classifier. I want you to be a texturer, a sketcher, a continuator, or a Picasso. Or a learner, which, this wasn't really, I don't think this got anywhere. These different classes we're going to be able to better see on the website. So yeah, so we have, we have these bots here that each of them had a different behavior. And at the end of the day, when I say behavior, is that they were using different machine learning models. For texturer, continuator, sketcher, everything they were doing was using pix-to-pix with a different trained model, so a different model that was just trained with different data, but they were the same machine learning model trained with different data, generating at the end different trained models. Model is a really, really complicated word. Let me just look for a reference here. Let me see if I can find this quickly. Yeah, I got it here. So if we look at this quote, we can see, I showed last week that I keep, so I keep this book. I keep this book and probably, yeah. Let me just see one thing. Yeah, so you can read it now, right? Oh, that's really dark. So yeah, this book here that I showed the other day, so the camera was flipped, you can read it. I got this description from there, and okay, we're back here. So this is a quote I highlighted and I have here on my computer with an application, online application that I'm proudly a subscriber of, that is called Readwise. It's really good if you're reading books on Kindle or other platforms on digitally to gather your highlights. And what this says is that, I'm just gonna read it. Confusingly, the same word model can refer to a type of model, for example, a linear regression model, to a fully specified model architecture, like linear regression with one input and one output. And similarly, could be a model architecture that could be Pix2Pix or StyleGAN or ResNet or many different models. Or the final trained model, ready to be used for predictions, like a linear regression with one output and one input using beta or like values or whatever, like specific inputs and outputs. So like trained on some or tuned for a specific set of parameters that are going to make it behave in a certain way. Model selection consists in choosing the type of model and fully specifying its architecture. Training a model means running an algorithm to find the model parameters that will make it best fit the training data and hopefully make good predictions on new data, right? So here, right, if we try to dissect Pix2Pix, so let's say here we say, what is Pix2Pix? So it's a generative adversarial network. So that's the model type, right? If we go back to that definition, that's the model type. If we say what's the model architecture, so its model architecture is that of a network. Well, that's actually, it's a bit confusing because that actually also defines the a generative adversarial network. That's like by definition, that's like what GANs are. It's model architecture is that of a network with an encoder and decoder, right? That tries to learn how to generate images, and then it's if we go back here, the final trained model, its final trained model adjusts its model parameters according to a set of training images to be able to predict the training image pairs, input to output, to be able to predict from a given input that we've never seen before, to predict an output synthetically generated from a given input that we've never seen before. All right, so that is in summary what Pix2Pix is. So model type, the model architecture, I would think we will have to define a bit better, but we could say things like input is 256 by 256 pixels, images are RGB or RGBA depending on the model. That's the model architecture, is the specificities of that model. And the final trained model adjusts the model parameters, and for example here is train to generate daisies or trees, or to colorize black and white images, right? So that's pick to pix. So that's the model that we have. So these three share the same model type and model architecture, but have a different trained model. So we have 3 different trained models. Actually, in texture, I have more than one. So I have one trained for daisies, one for roses, one for dandelions, one for sunflowers, one for sketches, one of trees, one for sketches of buildings with watercolors, another one for continuator that goes from trees trunks to trees trunks with branches to tree trunks with branches and leaves. Colorizer, I didn't get to train it. Classifier was just a classification neural network, and we'll see many of those. And rationalizer, I didn't get to do that one, but it would be something like trying to recognize the type of shape and try to rationalize it to a cleaner, a platonic shape. Learner was just like the concept of saving drawings that you were doing on the system to a folder, so you could then later use them for retraining or for learning from the data set and things like that. And that's what we're going to do in this series as well. All right, let's see what we have. So we were here. We're going to close this one. Oops, not that one. We're going to close this one, and we're going to see what we have here. All right. Okay. Okay, so before I think I closed it, but oh no, it's here actually. So I was looking here at the code that I was using. So for instance, for classifier, that it was a classifier neural network, I had inception that would recognize normal objects, and then man-crocodile. So man-crocodile was actually a test or debug model that would be able to recognize just between these two, right? So it would be able to recognize whether a drawing was something like the type of in the left or the type in the right. On the right. Okay, so there is a lot of code here, but at the end of the day, what you can see is that we had the reference to an image. So we had a reference to an image, and we downloaded the image when the image was ready, because the image takes some time to upload. I was waiting for half a second before downloading that image. There should be a better way to do that, just checking if the file exists or is ready until we proceed. And we would try to classify, make canvas square with software to classify and send the prediction. But what we're going to see here is that the process for texture, so the one that actually generates the images, was fairly complicated here, because we had to, we received the cropped image and the crop resize to match the network size, and also the alpha channel, so the channel with the alpha cropping that we wanted to use to crop the image as a layer mask. And then the output image was saved, and then the output masked and then resized back to the original canvas size, and then the output canvas. So there were many, there were many things that were happening, and they were all processed in the machine where the bot was running. A suggestion token, so a unique ID was provided for each of the strokes that were generated, and a timestamp, and also the stroke cropped. We resized to the canvas size, hard coding to the iPad's canvas size, I believe, or at least like a hard coded size in this case, and then uploading the suggestion, right? And then we will, after the suggestion was uploaded, this is like a Golang channel that would be sent to a variable here, and I have to refresh my mind to see what everything here actually means, because I haven't touched this code in a few months or years. And then at the end of the day, we say, okay, store suggestion. So we tell the server, store my suggestion. The parameter is suggestion true because it's sent by a bot. Let me zoom in a bit. So is suggestion true. Channel ID, so the server knows what channel this drawing belongs to. The timestamp where the drawing is generated, the token, suggestion token, and then the frame. So the frame are the origin and size. So the bounding box coordinates where this drawing needs to be stitched back when the suggestion is sent. And what we do is that we then downloading cropped stroke alpha, resize and invert stroke. We invert because the alpha channel is inverted, so we have a white background and black layer, and we actually need to invert that to have a layer mask. And before we continue talking, I'm just going to try to open some of those. All right, so in Golang, so we have the information. I think I have it here. So biggest folder, the server, and then on the temporary folder, I have all these strokes. So these are stroke, background, stroke. Yeah, so these are gzipped files. Let me see if I can make this bigger. So these are all gzip files that are right now on the cloud, so they're not in this computer. So if I copy, let's just copy a few of them and go to the desktop. And then, so we're gonna just make this a bit bigger. So we have this here and this here. Do I have unzip? Okay. Right. So I'm just trying to unzip this on the terminal. Don't remember the command right now. I don't know if I can just do unzip. So let me see, unzip 734.3 or whatever. You just copy this, unzip, period. Nope. Supposedly it's just this, right? Okay, that's empty. Unzip. Right, it's working. So just gunzip. So gunzip and the name of the file dataset. So we just put it here, and gets the stroke. Gunzip. Right. Yeah, so these are the strokes. So this seems to be the same stroke. And what you have here is that for the same stroke, we have the background, so there wasn't anything there. We have the drawing, and then we have the alpha mask. This alpha mask was generated on iOS. There's a way where you can make an image by drawing with paths, and I was using this stroke, right, the vector path of that stroke, as a mask. And this is what would be used then to crop the image suggestion. And I think, is this the same or is it different? Yeah, this is actually the same. I don't understand why. Let's see. Let me see if I can. Let's grab something that's bigger so we know that has some more content. Let's just pick randomly. Right, lucky. More. Right, yeah, so, we can see here is that I just randomly got stages. These are stages of drawings that are on the system. So if I just go through, these are just things that we sketched and we got suggestions for, and that are stored on the system as compressed images. So let me just maybe just open that. And some of them are just the empty background, and others are actual drawings with the merged things. So we have many of these that are raster, that are compressed, and that we could automate to get more of them, so we don't have to go one by one as today to unzip them. And the other thing that we built that you can take a look at is, I think it's just pix2pix.glitch.me. Yeah, so this is an interactive application in which you can draw, which is pretty nice. So we just tried to mimic a small part of that application on the web. Right now it doesn't do anything because I don't really have Runway installed here. If we had a model running on Runway, maybe I can go. Let me just try to go to Runway. App. Right. Just log in. Okay, so this is Runway, and I'm not familiar, have to say, with the web UI, but here we have let me just go back. So when I go back to the models, go to models, here I have, in my models, I have the Pix2Pix model, and I'm not sure if this shows up if I look on the web. Yeah, if I search for Pix2Pix, you can actually see this one. I don't know if everyone can see or if it's just me and Nate that uploaded the model. And we're gonna do, so live stream 3, for instance. So we're just gonna add a title here. And now I have the model that can run on GPU. I can't run it locally because how's this monitor with it? All right. Okay, so yeah, it seems like this version is a bit limited, but what you would do, because it's running on the web, and I understand that that's it's challenging to create networks on your local computer from a web app, because that's not safe and you can probably not even do it. Here, we have we could upload checkpoints that would be the trained models. We had for Runway, we have one that Nate trained on floor plans, so diagrams to floor plans, or like black shapes, like these ones to floor plan textures. And which one I had, you would use something more like this to just you just draw a flower, what I showed before at the beginning. And in Runway, what we would be able to do if we had it locally, so for next time I'll just write it a note to self to install Runway. So let's say here, install Runway locally. Well, install Runway. Yeah, and we're gonna move this to the bottom. So what you would be able to do here with Runway is that you would be able to come here on HTTP, and instead of hosting the model on the cloud, you would be able to run a local, or spin up a local HTTP server. In this case, you can also do Socket.io. That is another, like a similar protocol to WebSocket. I think internally it uses WebSocket and OCS. So these are different protocols to interact with the application from other applications or systems that are running on your machine. And here we have this field where you would put just, okay, it's running on port 8002 HTTP port, or 3000, or whatever port you put your application to. By default, Runway puts 8000 or 8001, or at least the local version that I used last time. And you can download, if you go to this app, so pix2pix.glitch.me, you can go, you need to have Runway installed, and you can click here once you have Runway to open the model in Runway and install it. I think using this link you should be able to see it. Again, credit to this experiment was done by myself and Nate. So Nate Peters did the model of the housing, and I did the one with the flowers. He's working on new things, I think, and he should be showing some of this stuff soon. There's some videos that we've done together, that this presentation demo, for instance, you can go watch, that talks about this process if you want to learn more about the process that we were using these models with Runway on the cloud. And just to let you know, it has chapters, so you can see, you can go and select different chapters, and Nate can explain how this is working. Maybe we can play a bit of this.
So I'm going to pick GPU. And there's a few image editing tools here. So you can rotate, mirror. Essentially, this is the, so we're going to use these tools to actually drive the GlitchMe app, but there's also like, a fully kind of hosted set of tools inside Runway. So you can use it in isolation if you want to. And then the other set of tools here for models that are running remotely is all of these endpoints. So a few people have been asking, can I use Runway from, tool A, ABC, whatever, Grasshopper. The way that Runway is kind of designed to, and then I'm going to add in the correct value there, and you'll see automatically it connects, and then it's going to start serving predictions. And so what's kind of cool is that it's actually, it's going to use the GUI. It's going to run. It's essentially going to treat it the same as if you'd opened up a file locally, or if it had received a request. And there's a new kind of magic tab that opens up here. I think this only shows up if you've actually run something through the network to the model, but this will essentially be kind of a new model space that'll preview the data that it's processing. And so the next thing I'm going to do here is then switch to a different model. So when we built this in Runway, we trained multiple different data sets on the same source code. And Runway gives you tools to upload multiple kind of representations of the same model. So here I've switched to Nono's Daisy's model, and then I'll badly use my Mac trackpad to try to draw a flower. I wish I had an Apple Pencil. But you can tell, now it's not generating houseplants. It's obviously running on a totally different set of model weights.
It's hard to draw with the mouse.
It's super hard. Yeah, that was like my third attempt, and they're all terrible.
Okay, I'm back. So yeah, so we have these videos here. You can use them. Actually, one thing I didn't comment on, glitch. You can go here at the top, so you see this fish here, the glitch logo, done by Nate and myself, and you can view the source. So you can click on view the source, and you have full access to our HTML, JavaScript, and CSS code that we used to develop these, specifically this application. So it takes a bit when you leave a project in Glitch that is not active for some time, but let's see if this loads. Loading project. And if you click on remix on Glitch, you'll be able to to just clone the application and then start editing right away. So pix to pix. Sure, what's going on? Okay, yeah. So this is, for instance, a markdown document. You can click on seeing the markdown, edit here, and format the file. Well, not format the file. Arc. And okay, it's getting late, so we're gonna have to wrap up fairly soon. We've been online for I think an hour and 20 minutes now. Let's see if I disappear from here. Right, that's better. Right, yeah, something's going on here, so we're not really going to be able to see it, or what? Well, I have it here, so you can see the HTML. Let me just make this bigger because it's really hard to see. HTML, the JavaScript, the CSS, and some other stuff. And if you were to preview this on the site or full screen, so we can we can just have this here, and as I don't know, for instance, change something here, so just add an artist. This updates in real time, and you get that. So you get the preview, the interaction, and everything updated in real time. Right. Okay. So yeah, I think I've covered more or less what I wanted to cover today. I've said a few of next steps of where we can go and some of the things that I would like to take a look at. I would also definitely like to maybe go through my sketches, so my drawings, and create a new data set that we could probably train a data set, or not train a data set, but like prepare a data set to train style gun with sketches or something from the data set of the Suggestive Drawing server, or train pix-to-pix models. So I have this image here that has many of my drawings. So these are like hand sketches that I do. So I'm navigating here, just zooming in, and I have many of them, and I edit many of them. So one of the interests of mine is to get them all edited individually, maybe build tools that allow me to classify them by class. So say, is this a chair, is this a house, is this a hand, is this a car, or is it a building? To classify them, maybe even to input a sketch like this one in black and white, and then get something textured, or do some other operations like style gun to be able to browse the latent space and see everything that is in there. And yeah, so that's the sketches data set. So that's his sketches data set, right? And I showed this, I think, last week, maybe 2 weeks ago. I showed it in another video, but here is part of the data set that I'm building. So these are my own drawings. So these are things that I've, if I zoom in maybe a bit more, you can see them widely. So these are sketches that I do by hand. So I look at something and I sit and sketch with my pens and my watercolors. And as you can see, some of them have watercolors, some of them have like a slightly different style, some of them are more minimal like this one. There are many different, some of them have labels. And I would like to start building machine learning models to understand them a bit better, to generate similar things, or just to understand what you can do with the technology that we have right now for machine learning. And I think models that we build with this data set could be really nice for a suggestive drawing machine learning model, right? Each of these, I've shown this sometimes, but each of these comes with a little story. So these are like short essays that I write on wide variety of different topics, and many of them, let's say like this one that talks about going to Patrick Winston's class at MIT, end up being not only a sketch, but also a podcast episode on getting simple. So you can see, for instance, here.
Early morning on December 20th, 2016, I found my way into a huge sports field at MIT, plagued with evenly spaced tables ready for an exam. Nervous? As if I were back to school. I was the first one to get there. Our professor would get there a bit later.
Yeah, so this is like essays that I've written that have to do with those sketches, and in particular this one, this is why I showed it, is talking about me meeting with Patrick 3 years ago to ask him what he thought, and handing him the system. So this was actually sketched by Patrick Winston on the system, and seeing what he thought of the tool or where it could go and stuff. So he sketched these two flowers, and then we received these two predictions on the system, and then the iPad displayed these two images. This is the process of, I have two images, so two sketches, two strokes. We get a prediction that we don't really see, and then it gets post-processed, and then we receive it as is shown here on the end client where we'll draw in, right? And yeah, and this is Patrick Winston. Okay, so one last thing that I might be able to show on, I have here, I don't know if we can see it, maybe here. Yeah, so I actually have a hidden section of suggestive drawing that I didn't publish, that I have some other drafts, some other explorations. I trying to classify this image with Inception on the command line with a Go inference sample program, getting it classified 63% as a reflex camera, which is pretty good. Lens cap, tripod, some links, some other diagrams that I thought of doing. This I really particularly like, which is, this is how Mathematica shows you the process in which it's not visual programming, but it's like sort of equation visually programming, where you say, okay, color negate, which is inverting, detecting the edges, and you do first get the sketch, detect the edges, and then invert it. And some other diagrams, associative drawing. So this concept that I mentioned before about having a way where you sketch and you see this blue box that is telling you, like, when I get closer to your drawing, I'm going to group that part of your sketch and make it an individual application. And you can see how it works a bit better here. An example. All of those are independent strokes, but are then considered by the final system as the same thing. Here, we have a diagram that shows, okay, somebody can put their circle, somebody can complete the flower, somebody can put the texture, which is a bot, so two humans and a bot collaborating in the process. Some of the archived files, delegation, creative mediation. Yeah, so one thing that was a bit, not dangerous, but something that I didn't end up doing, the motivation for this project wasn't really saving the artist's time. Educate the apprentice and inspire the creative. Maybe inspiring the creative, maybe sparking something different that he wouldn't have thought of, but to say this is not something to save time. That's something that maybe Photoshop is trying to do, or some other applications, and then also educating the apprentice if you do work for it. So if you're the one filling in with texture, then that's not really showing, that's actually doing the job for him, maybe giving him reference of how things could be done, and then giving a spark on next steps, right? So I have some thoughts that I wrote here, other things on processing portraits. These are portraits made by Lourdes Alonso Carrion, that's my mom. And this is just sketch recognition, trying to recognize between a circle, a square, a cross, so like a rotated box and a circle. Yeah, I don't know, it's a bit weird. Strokes on the system. This was doing object recognition on the sketches that I was sending. This is an idea I didn't really get to. You can see this really well implemented on the latest iOS 14 interface. This was the continuator model that I ended up doing with trees. These were some of the explorations I did with Mathematica, where you could process the same image and merge it with multiple parameters and see which one was working best. So for instance here, I think maybe this one or this one are the best, whether these ones don't have enough detail. And you could see, you could see this in many images and see, okay, I have to get to this level of contrast first to get to this edge detection result with MATLAB actually in here. Yeah, this was a good exploration. So using the same input with multiple agents, right? And seeing how, well, this is the data set. But this is what I was mentioning before, where you have the stroke. So the iPad generates the stroke that you've sketched, then makes an alpha mask, then the bot generates a suggestion, and then the bot crops the image for you and sends it through. So by sketching this, you end up with something like this, even though in between these two images are being generated. Same for this, input this, generate that, crop it like this one, and then some other tests. Same image and 3 different inputs. So same image, and then trying to make a daisy, sunflower, and a dandelion. And some explorations on urban sketching, so trying to color diagrams of like perspectives of buildings. This was really, really fuzzy. This is one of my favorite things to do. So you have an input, and you just rotate it and pass every single frame through the network, and then see what happens. Pretty cool effect on the background colors. And I think that's it. Yeah. All right. Well, this was the first session of suggestive drawing. So let me just open that back. Where are you? Again, if you got this far, or if you're online at the moment, I would encourage you to like the video. If this is a sort of content that you'd like to see, if you're excited about the suggestive drawing series and the machine learning series, and I encourage you to subscribe if you want to get notified when I upload new videos or when I go live. Last thing, so let's see. So this is part of the machine learning series. And now I'm just gonna stay here. So if you have any questions or any comments, I'll be glad to answer them. And yeah, if you're online, let me know where you're connecting from, and let me know what you would like to see in future episodes, or live streams. And maybe while we are waiting to see if somebody has any questions for me or any last thoughts or comments, I'm going to do something that I had to do, where, I'm going to stop recording. Right? And I'm going to Right, so we're just gonna do something. We're just gonna record here something live that I need to record for the channel, and we'll do it live right now. Let's see if this is useful. Oh, we have some weird lightning here. All right, we'll do this later. All right, if nobody has any questions, I just want to say thank you. Thanks for connecting online. Thanks for watching. I hope you really enjoyed it. We're going to continue with this series. I'll try to continue it once per week, but maybe next week we can do it. I'll be announcing day by day. And again, thanks so much for watching, and I'll see